Welcome, everyone. Today we are exploring a game-changing aspect of modern AI, Claude's multimodal capabilities. We're going to learn how to seamlessly blend text and images to unlock powerful transcription, visual brainstorming, and complex chart analysis. Let's get started. Let's start with the big picture. When we talk about Claude's multimodal capabilities, we are primarily talking about its powerful vision engine. Think of it as giving eyes to your AI. By default, Claude accepts standard formats like JPEGs, PNGs, and WebPs. Why does this matter? Because a picture is literally worth 1,000 words of context. Instead of spending 20 minutes describing a complex system architecture, you can simply upload the diagram. Whether you are dragging and dropping into the web interface or piping data through the Messages API, Claude processes these images by converting them into tokens, analyzing them directly alongside your text prompts for deep, unified comprehension. Looking at this flowchart, you can see the convergence of our inputs. On the left, both image inputs and text prompts feed simultaneously into the Claude multimodal engine. The engine fuses these modalities, branching out on the right into actionable outputs, visual analysis, transcription of handwritten or printed text, and precise data extraction. It is a unified processing pipeline. So, how do we actually use this in our daily workflows? The most immediate value comes from transcription and chart analysis. Imagine finishing a chaotic brainstorming session. The whiteboard is covered in messy diagrams and notes. Instead of manually typing it all out, you snap a photo, upload it to Claude, and ask for a structured summary. Or consider financial charts instead of squinting at a complex scatter plot. You ask Claude to extract the exact Q3 revenue figures. This eliminates manual data entry and reduces human error. Furthermore, you can use this for visual brainstorming. You can literally draw a website wireframe on a napkin, upload it, and have Claude generate the starter HTML and CSS code. It bridges the physical and digital worlds. This diagram maps out our core use cases. From the central vision node, we branch into transcription for digitizing handwritten notes and legacy documents. We branch into chart analysis for extracting financial data and identifying trends. Finally, we branch into visual brainstorming, which empowers us to go straight from a low-fidelity wireframe sketch to deployable code. As senior developers and architects, how do we pipe this visual data into our applications programmatically? The Messages API provides 3 distinct methods. First, we have base64 encoding, where you convert the image into a massive text string and embed it directly in the payload. This is fine for simple, local scripts. Second, you can pass a URL if the image is already hosted online. But the third method, the Files API, is what you should be using for enterprise apps. We will explore exactly why the Files API is so critical in a moment, but understand that Claude's API expects an array of content blocks, meaning you can easily mix one text block and multiple image blocks in a single, elegant API call. Here we see the 3 distinct integration pathways connecting your client application to the Claude API. The top path sends a heavy base64 string. The middle path sends a lightweight image URL. The bottom path utilizes a file ID from the Files API. All 3 successfully deliver the visual payload, but they have drastically different implications for network bandwidth. Prompt engineering changes slightly when we introduce images. The golden rule here is structure. Always provide the image before the text in your prompt. Think of it like handing a colleague a report. You give them the document to look at first, and then you ask your question. If you put the text first, Claude might process the instructions without the full visual context loaded in its working memory. Additionally, image quality matters. Don't crop an image so tightly that you lose the axis of a chart just to make the text bigger. Finally, for advanced workflows, you can actually equip Claude with a crop tool. This allows the model to actively zoom in on specific parts of a dense image, vastly improving its analytical accuracy. This sequence diagram illustrates the optimal payload structure. Notice how the API payload first sends the image content block, immediately followed by the text content block. The note highlights the cognitive benefit. The model absorbs the visual context first, creating a grounded foundation before it attempts to execute your specific text instructions, resulting in a high-accuracy response. Let's talk economics and performance. Images are not free. They consume your token budget just like text. Claude literally slices the image into patches and converts them into tokens. The higher the resolution, the more tokens it takes. For example, Claude Opus 4.7 supports incredibly high-resolution images up to 2,576 pixels, which is amazing for reading tiny text on a dense architectural blueprint. but it can cost up to 4,000 tokens per image. If you are just asking Claude to identify if a picture contains a dog or a cat, you do not need 4K resolution. As a best practice, programmatically downsample your images on the client side before sending them to the API if high-fidelity detail isn't strictly required. This saves money and dramatically reduces latency. This decision tree is a great mental model for your architecture. Starting with a raw high-resolution image, we ask, do we need fine details? If yes, we route it to Opus 4.7, accepting the higher token cost for maximum fidelity. If no, we aggressively downsample the image and route it to a faster model like Sonnet 4.6, optimizing our system for low cost and high speed. Here is the most critical technical pattern for multi-turn visual chats, the Files API. Remember that Claude's API is stateless. To maintain a conversation, you have to send the entire chat history back to the server on every single turn. If you use base64 encoding for an image, you are sending megabytes of text on turn 1. On turn 2, you send it again. By turn 5, your payload is massive, your app is lagging, and your network is choking. The solution, the Files API. You upload the image once to Anthropic servers. They hand you back a tiny file ID. As shown in the sample JSON code on the slide, you simply reference file ID, file 123, in your content block. Your payloads remain microscopic, completely eliminating network bottlenecks during long-running, agentic visual workflows. Observe the stark difference in these two loops. In the top base64 approach, the payload compounds exponentially 5 MB, then 10 megabytes, then 15 MB, crushing your network. In the bottom Files API approach, we pay the 5 megabytes upload cost exactly once. Every subsequent conversational turn just passes a 1 kilobyte ID. It is a massive architectural optimization. Let's put this into a real-world scenario that delivers massive ROI, automated financial analysis. Imagine an analyst who receives a 50-page scanned PDF slide deck of quarterly earnings. Instead of manually staring at charts and typing numbers into Excel, our app uses Claude. We pass multiple images of these charts into a single prompt. Because Claude can process multiple images jointly, we can ask it to cross-reference them. We can say, look at the Q3 revenue bar chart in image 1 and compare it to the supply chain cost line graph in image 2. Claude uses its multimodal pattern recognition to instantly spot that a revenue dip perfectly correlates with a logistics spike. It extracts the exact figures and writes the executive summary. We've just turned hours of tedious visual data mining into a 5-second API call. This state diagram maps out our financial analysis agent. We start by ingesting the raw reports. We extract the relevant images, which feed directly into Claude's multimodal analysis engine. From there, we move to a data validation state, perhaps a quick programmatic check before generating the final executive summary and concluding the workflow. As senior engineers, we must know our system's limits. Claude is brilliant, but it has strict safety guardrails. It will actively refuse to identify specific, real people in photos to protect privacy. It also cannot reliably tell you if an image is an AI deepfake. Furthermore, while it can read medical charts, it is absolutely not a medical diagnostic tool. Technically, Claude also struggles with precise spatial reasoning, like reading the exact minute on an analog clock or counting hundreds of tiny objects in a crowd. Always design your apps with these limits in mind, and keep a human in the loop for high-stakes decisions. If you found this deep dive valuable, please like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and comprehensive interview guides. Thank you for watching. Our final diagram illustrates the safety boundaries. Every image upload hits a safety filter. If it contains personally identifiable faces, it routes to a refusal. If safe, it evaluates the task type. High-stakes medical or precise spatial tasks route to a mandatory, human verification required state. Standard text and chart extractions route cleanly to our high-confidence output.